Good news everyone! We are starting a new series of short episodes on laser communication. I am David, product manager at Cailabs, and I am very glad to welcome you in this first episode. In this series, we are going to talk about light and how we can manipulate it, about spatial modes, MPLC, and overall how we can improve laser communication through the atmosphere. But before that, let us take a quick look at Lasercom in general. Lasercom is a technology that uses light to transmit information. But unlike today's internet backbone, in which data travels through optical cables, in Lasercom, light propagates directly in free space. This has several advantages. It can theoretically transmit information at almost an unlimited throughput and almost everywhere, with a satellite, an airplane, or even a ship. So why is it not already widely used? In general, deployment of a technology is governed by several aspects, like do customers have needs, is the technology mature, and how much does it cost? In terms of needs, radio frequency technology has so far been able to cope with data transmitted in free space. But things are changing very quickly, with the volume of information growing crazy. For example, the next Airbus satellites, called Pléiades Neo, with their high-resolution cameras, will each be able to record 40 terabytes of data per day. Bringing this information back to us will require a very high-speed communication link that only Lasercom can provide. One question is then, do we have the technology for Lasercom? It's a bit more tricky question, but overall, if we look at the telecommunication ecosystem, plus the demonstrations that have already been done by space agencies and companies, we can say that the technology is indeed close to being mature. Bringing us to the last aspect, how much does it cost? In telecommunication, a good metric is the cost per byte, and a good order of magnitude is few dollars per gigabit. So, to be competitive, Lasercom will need to use standard, inexpensive, and off-the-shelf components. Fortunately, almost all of these components are already available. You can find standard high-speed transceivers, detectors, amplifiers, and so on if you look at the current telecom optics technologies. The only component that still needs to be standardized is the interface between Lasercom and existing fiber components. So, to sum it up, we see that there is a need for Lasercom. The technology is becoming available, but to be competitive, the architecture of Lasercom will have to be able to interface with standard fiber components. With this interface, we can bet that Lasercom will spread to a wide range of applications. Providing this free space to single-mode interface is one of Cailabs' jobs. And in the next episode, I will develop the technological challenges and what we can bring with our technology. So thank you very much for listening, and see you soon in the next episode.